In this video, we're going to be looking at direct and inverse proportion. And this is quite a long topic, but hopefully after I've explained it, you'll kind of understand what's going on. When we talk about direct proportion, that would usually mean that as one thing increases, the other will increase as well. Okay, so it's just a relationship or correlation between two variables, x and y usually, but it could be any letter. And you could say, if I had something like this, as x increases, y increases as well. So this is kind of a direct proportion. As one goes up, the other one goes up, is the idea. So I might say in a question, y is proportional to x. And when you see that in a question, we write down y equals kx. So this equals k is our in to this question. This is how we start the question. Y is proportional to x. We just replace proportion to equals k. And our job is to find k. This whole topic is basically what is k. All right. So at the moment, there's no way of knowing what k is. It could be literally anything. So they will give you some information when y is 10, x is 5, or something like that. Any kind of numbers, it's not really important. But whatever those numbers are, we substitute into our equation. Y is 10 equals k times x, which is 5. Essentially, we have 10 equals 5k. So we can divide these two to work out k, divide both sides by 5, and we get 2. And then once we have our value of k, we must reinsert this into our original equation. Y equals kx, like that. And that's it. All we have to do is use the numbers to find k and then rewrite the equation at the end. Often students get to this point here and they go, yeah, I've done it. I found k. But it says write your equation in terms of y and x. And we forget that last little bit. Okay, now how do they make this topic harder? Well, the clue is in the wording, okay? So they will say something like y is proportional to the square of x, which is super annoying because they could just say x squared, but they don't. They say the square of x. And the only difference is we put that there. When we do our substitution, that would be there. So it would change our final answer for k, but the method would be exactly the same. They can also say the cube of x. Again, super annoying, but we don't change how we do this. It just adds a couple of extra steps where we're working out the cube instead of just putting the 5 in there. And they say the root of x. Okay, so the only difference is what happens to x. Is it x? Is it squared? Is it cubed? Is it rooted? Like, that is the only difference. We still work out k and put the k in here at the end. Okay, what about inverse proportion? So if a question says y is inversely proportional to x, we say equals k, but we put over x. All right, this is the only difference. Inverse proportion is k over. So it could be x, it could be inversely proportional to the square of x, or the cube of x, or the root of x, which may look scary about how we solve these and everything like that. But the actual inverse proportion and direct proportion part is finding k. Okay, so if we have something like y is proportional to the, inversely proportional to the square of x. Then we need some information. So y equals, let me think here, 2 when x is 5. Okay, so exactly the same format. We're going to substitute y equals 2 equals k over x squared. Whatever x is, we're going to square it, which is a 5. Okay, so we tidy this up a bit. 2 equals k over 5 squared, which is 25. And we need to times both sides by 25 to get rid of this. K equals 2 times 25 is 50. So we found k, but we're not finished yet. We have to re-substitute that into our original equation. Students often try to keep the numbers in here. No, go back to the original equation. Y equals k, which was 50, over x squared. And that's it. Okay, so direct and inverse proportion is all about writing it out in the correct manner with the equals k for direct and equals k over for inverse, and then substitute the numbers, find k, and rewrite the equation once you know what k is.